Have you ever looked up at the night sky and felt like you were staring into a void? What if I told you that the darkness isn't empty, but filled with a celestial fire that has been burning since the dawn of time? For thousands of years, humanity was blind, trapped on a rock, believing we were the center of everything. But then, a few rebels dared to steal fire from the gods, not with magic, but with a simple piece of glass technology. It sounds impossible, right? That a fragile lens could shatter the heavens and rewrite our place in the universe. But this isn't just a story about telescopes. It's the story of a visual revolution that forced us to confront a terrifying truth. We are small, and the cosmos is vast. It's a paradox. The more we see, the less we understand. Yet, this very act of looking is what makes us giants. So buckle up, because we are about to embark on a journey through time and space. We're going to uncover how a simple tool became a time machine, allowing us to peer back to the very moment of creation. This isn't just history, it's the blueprint for our future. Are you ready to see the universe with new eyes? Let's dive in. Imagine a man in 1609, not in a sterile lab, but in the bustling streets of Venice, hanging out with gritty lens grinders. This was the Silicon Valley startup of the 17th century, where the real hustle happened. Galileo didn't invent the spyglass, but like a true visionary, he pivoted its purpose. While everyone else was looking at ships on the horizon, he pointed his glass technology straight up at the heavens. It was a bold move, a visual revolution that took a military tool and turned it into a key for unlocking the universe. He wasn't just looking, he was hunting for a cosmic perspective that would shake the foundations of society. Now you might wonder how a couple of pieces of glass can bring the stars down to Earth. Think of his telescope like a giant funnel for light, or better yet, a visual accordion. The big lens at the front grabs a massive image of the moon and squeezes it down, concentrating all that celestial fire into a tiny, intense point. Then, the eyepiece takes that squeezed image and stretches it back out so the human eye can digest it. It's a simple trick of refraction, bending reality just enough to let us steal a glance at things we were never meant to see. When he finally looked through this glass time machine, the perfect heavens shattered. The moon wasn't a smooth, divine pearl. It was scarred with craters, rugged and messy, just like Earth. And seeing moons dancing around Jupiter proved we weren't the center of the universe after all. It was a moment of pure awe, mixed with terror. But this early stargazing tool had a dirty little secret. A nasty habit of distorting the light it captured, creating a problem that would drive the next generation of geniuses absolutely mad. Remember that dirty little secret mentioned before? It was a ghost in the machine. Every time early astronomers tried to push their glass technology further, the stars looked like they were bleeding color. It's exactly like watching a 3D movie without the glasses. Everything has this annoying, fuzzy rainbow halo around it. The glass was acting like a prism, splitting the pure white celestial fire into a messy spectrum. It was a wall, a limit to human vision that seemed impossible to break, frustrating the greatest minds of the age. Enter Isaac Newton. A young man who didn't just accept the rules. He rewrote them. He realized the problem wasn't the shape of the glass, but the glass itself. So, in 1668, he ditched the lens entirely for the main gathering element. Instead of forcing light through a medium that distorted it, he decided to bounce it. He used a mirror. It was a radical shift in stargazing, moving from the squeezing of refraction to the clean, crisp rebound of reflection. This change was monumental. By using a curved mirror at the bottom of the tube, the light bounced back up, pure and uncorrupted by those rainbow ghosts. It meant we could finally see the universe in its true colors. This visual revolution opened the door to building massive beasts of observation, far larger than Galileo could have ever dreamed. But just as we were getting ready to build these giants to peer deeper into the dark, a new challenge emerged from the very air we breathe. William Herschel wasn't just looking at the stars, he was listening to the visual symphony of the cosmos. As a musician, he understood that to hit the lowest, deepest notes, you need a bigger instrument, like a massive pipe organ compared to a flute. He applied this same logic to his glass technology, building mirrors not just to see better, but to see deeper. He knew that catching the faint whispers of ancient light required a bucket, not a thimble. So he constructed the Leviathan, a beast of a telescope that dwarfed everything before it. It was a visual revolution built on the idea of light-gathering power. Imagine standing in a dark rainstorm with a teacup versus a swimming pool. The pool catches way more drops. Herschel's giant mirror was that swimming pool for celestial fire, capturing photons that had traveled for millions of years, too weak for smaller scopes to even notice. When he pointed this monster at the sky, the fuzzy, milky patches that confused everyone else suddenly resolved into diamonds. He realized these weren't just clouds, but islands of stars, clusters and nebulas hanging in the void. It gave humanity a terrifyingly vast cosmic perspective, showing us that the universe was deeper and richer than we dared imagine. But as we peered further out, we started running into an invisible wall, a shimmering barrier right above our heads. We built these massive buckets to catch light, but there was a ceiling we couldn't break. The air itself. Imagine trying to read a book that's sitting at the bottom of a swimming pool. Now, imagine a bunch of kids cannonballing into that pool. The words on the page would wiggle and dance, right? That is exactly what our atmosphere does to starlight. It's a turbulent ocean of air that bends and breaks the image before it ever hits our glass technology, blurring the sharp reality of the cosmos into a fuzzy mess. We write songs about "Twinkle, twinkle, little star," but to an astronomer, that twinkling is a nightmare. It's not romantic, it's pure data corruption. It's the heat rising from the pavement on a hot day, blurring the horizon. That shimmer destroys the details we fought so hard to capture. It meant that no matter how big we built our mirrors on the ground, the celestial fire would always be a little bit out of focus. We were stuck behind a frosted window pane, unable to see the universe clearly. But humans are stubborn creatures. If the air wiggles, we decided to make the mirror wiggle back. We developed something called adaptive optics. We shoot powerful lasers into the sky to measure the distortion, and then, in real time, computers warp the shape of the mirror hundreds of times a second to cancel out the atmospheric dance. It's like noise-cancelling headphones for your eyes. This visual revolution cleared up the view from the ground. But even with lasers, there was one final frontier we couldn't cross without leaving home entirely. We finally realized that to truly see the universe, we had to leave the swimming pool entirely. We had to launch our glass technology into the cold, clear vacuum of space. This was the ultimate solution, the only way to escape the atmospheric noise and see the cosmos in its raw, unfiltered glory. It was a leap of faith, sending our most precious eyes into the dark, where no human hand could fix them if something went wrong. But once we got there, we unlocked a true time machine. With the James Webb Space Telescope, we aren't just looking at distant objects, we're looking back in time. When you look at the moon, you see it as it was 1 second ago. But when JWST peers into the deep infrared, it sees the celestial fire of the very first galaxies born after the Big Bang. It's cosmic archaeology, digging up the fossilized light of the universe's infancy. To do this, we parked the telescope in a special spot called L2, 1,000,000 miles away. Think of it as a quiet parking spot in space where the gravity of the Sun and Earth balance perfectly. It allows the telescope to hover in Earth's shadow, shielded from the heat and light that would blind its sensitive instruments. From this vantage point, we have finally achieved a cosmic perspective that reveals the dawn of time itself. And as we stare into the abyss, we realize that our journey has only just begun. We've traveled from the gritty streets of Venice to the silent, cold parking spots of deep space. We've seen how a simple piece of glass technology evolved into a time machine, allowing us to steal celestial fire from the very edge of creation. But here is the real question. What are you doing with your perspective? Are you still looking at the ground, distracted by the noise of the atmosphere? Or are you willing to build your own mental telescope and see the bigger picture? The universe doesn't hide its secrets. It's waiting for you to be brave enough to look. Just like Galileo, Newton, and Herschel, you have the power to shift your cosmic perspective and see beyond the obvious. So I challenge you, what lens are you using to view your life today? Is it clouded by fear? Or is it polished by curiosity? The tools are in your hands. It's time to stop just watching the stars and start reaching for them. If this journey sparked a fire in your mind, don't let it burn out. Join our community of visionaries. Subscribe to the channel and turn on notifications so you never miss